right, so in this video we're going to talk about how we actually make solutions and how we take solutions that are already created and then change the concentration. So we can take a super concentrated solution like hydrochloric acid, the 12 moles per liter, and then I can dilute that down into a new molarity. So essentially I'm going to take that concentrated acid and I'm going to add water. Now, I'm going to teach you how to calculate that amount out. So when we have something that's very concentrated and we want to dilute it down, we need to figure out how much of that concentrated solution do we need, and then we're going to essentially take that, measure it, and then add water to it until we get to a new molarity. So this is the equation that you're going to use to figure that out. So M1 represents the original molarity. This is always going to be the higher molarity. Now, V1 represents the volume that you will measure of that concentrated solution. M2 is going to represent the new concentration. What concentration do you want the solution to have? And then V2 will be how much do you need? So V2 will be whether you need a half a liter, you need 2 liters of that new solution. So something to note, when you dilute a solution down, the amount of solute that you have is still the same. It's just now you've changed the ratio of the solute to the solvent. Now, let's say that you have a solution, you have 5 moles in that solution, okay? If you just add water to it, you still have 5 moles, but you have changed the molarity. You've changed the ratio of moles of solute to the volume of solution. You have done that, but you haven't actually made it less. So you haven't taken away moles of the solute. So the moles of the solute will remain the same in this, just you're going to change the concentration. You're going to change the ratio of moles of solute to your volume of solution. Okay, so let's see how this was done. So what volume of 15.8 moles per liter solution of HNO3 is required to make 250 milliliters of a 6 molar solution? So now what we're going to do, we're going to pull out all the information. So 15.8 moles per liter, that's a molarity, and that's the higher one, so that's the original molarity. All right, then it's asking for the volume that you are going to measure of that. So you're looking for V1. Then it tells you that you're going to make 250 milliliters, so that's how much you want of it. That's going to be your new volume. And then M2 will be the new molarity that you want it to be, which is going to be 6. All right, so now we can just plug everything into the equation. You don't have to convert your volume if you do not want to, because this is essentially a proportion. So if it's milliliters, you're going to get milliliters on the other side. So M1 is 15.8. V1 is what I'm looking for. I want to know how much of this 15.8 moles per liter solution I'm going to measure out. M2, the new molarity, is going to be 6. V2 is going to be 250. So I want to have 250 of the 6 moles per liter solution. So I'm going to calculate this out. And then divide both sides by 15.8 to get the V1 by itself. So V1 is going to be equal to 94.9 milliliters. So that is how much you're going to measure out of this concentrated solution. So what you will do is you will measure this. You're going to add it to a container. Usually we add it to something called a volumetric flask. And then we will add water until we get to are 250 milliliters. All right, so if we're talking about making a solution from a solid, okay, the way that we're going to do that, first thing, if you're going to do this, if you want a solution to be 1.54 moles per liter of the sodium chloride, and you want 500 milliliters of this, the first thing that actually happens is a calculation. Because when you go into a scale, you go into a lab, you're going to have a scale that measures grams, and then you're going to have things that can measure volume, but you don't have anything that's going to measure this. So you have to do a calculation first. You have to know how many grams of the sodium chloride are you going to need. So we have 500 milliliters, so I want to make 500 milliliters. I want it to be this concentration, and remember, molarity is a conversion factor between moles and liters. So 1.54 moles is equal to 1 liter. So I have 500 mils that I want, so I'm going to start off with my volume, because I can go from milliliters. I want to go to grams because that's what I want to measure out, okay? So I need to go to liters first because I have a conversion factor that goes between liters and moles. Then I can go to moles, and then I can go to my grams. So those are the steps that I'm going to take in my conversion. So I have 500 milliliters. I'm going to go to liters first, follow the map, milliliters on the bottom. 1 liter is equal to 1,000 milliliters. Follow the map, moles on top, liters on the bottom. The conversion factor between moles and liters would be the molarity. There are 1.54 moles, and that's equal to 1 liter of solution. Now I can go to grams, grams on the top, moles on the bottom. 1 mole is going to be equal to 58.5 grams. That's the molar mass of sodium chloride. 1 sodium plus 1 chlorine. And then when I get this, it's going to say 45. So what does this mean? This means you need to go measure out 45 grams of the salt. And then you're going to add that salt into something called a volumetric flask. This is a volumetric flask. This is the most precise measurement to make a solution with. So you're going to go measure 45 grams of the sodium chloride. You're going to add that to your flask first. Now, a volumetric flask only measures 1 volume. So I have 100 milliliter volumetric flask, I have 250, I have 500, I have 1 liter volumetric flask. That line at the top is where you're going to fill the water to, because that is the 500 milliliter mark. Now, you can't fill this halfway and say it's 250. That does not work. You can only use whatever that volume is. So you're going to make 500 milliliters by adding your salt first, and then add water until you get to the line. And then at that point, you're going to make sure that you dissolve the salt.